Hello and welcome to this session. This session it's 30 minutes to kickstart your AWS AI and machine learning knowledge. Allow me to introduce myself. My name is Bruno Amaro Almeida, and I'm a principal architect and advisor at Futurize. So what can you expect from this session? We're going to learn core data science concepts. I will introduce you to the AI and machine learning landscape in AWS, uh, giving us the fundamentals of what does it mean to do data architecture in AWS, and essentially giving you, explaining you what does it mean to build, train, and deploy a machine learning model in AWS. Now, I work for a company called Futurize, which is a digital innovation and engineering consultancy company, headquartered in Helsinki, where I'm based. Um, and working with different engineering teams, I noticed that it can be quite hard to understand at first the field of AI and machine learning. So based on my own experience and also from multiple developers and DevOps teams, it can be really hard if you are working day to day in AWS, but you are not working in this field, to actually understand what is this all about. Actually, what can you do? What are the tools that are there? What are the services for? So this session is essentially, I'm not a data scientist, but this session, I want to explain to you and give you a crash course on what the terms mean and what are the reasoning behind them and what are the services available and essentially what can you do with it. So starting from the very basics of what is AI, machine learning, and data science, and all of these terms. So artificial intelligence is not a new word, and essentially are computer systems that accomplish goals in doing some tasks. It's not a single thing, it's a combination of different technologies, and machine learning is one of those technologies. Machine learning is essentially a toolbox of algorithms, in mathematics, so algorithms and techniques that learn rules from data. So it is a way to implement AI in narrow tasks. It's not magic. It learns from the data by minimizing a cost function. And you probably also heard the term deep learning, and deep learning is very popular nowadays, and is one of the most popular tools from the machine learning toolbox. It's a tool that is particularly effective when the data set is very large. So essentially, in a nutshell, deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. So I think this part is fairly clear to majority of people, but there's so many terms around. So what about all of these other terms, like big data and data engineering and data science? What is what? So all of these terms are very distinct, but they are very dependent on each other because they are very related. So when we talk about data engineering is essentially software engineering practice of designing, building, integrating, and managing data. When we talk about big data, is essentially a subset of that. It is about how to extract information from a very large data set, which includes capturing that data, storing, querying, and visualizing it. And when we talk about data science is not the same as artificial intelligence, but artificial intelligence is part in a way of data science. When we talk about data science, is essentially in the interdisciplinary fields to extract knowledge from data, which means that it encompasses artificial intelligence, machine learning, deep learning, big data, and data engineering. They are all about data. They are all belong to the data science term. So once you start working with AWS and you start exploring about all of the AI and machine learning and data engineering services, you might get very confused very fast because there's a lot of different things available. And I tried to group them into this kind of four buckets. So when we talk about ETL, and I'm going to explain a bit more in detail what ETL is all about, but when we talk about ETL, you can use AWS Glue or you can use AWS EMR. And essentially it can get very confusing, like what you should use. So if you use AWS Glue, you can do ETL, which is essentially transforming your data. And you can use it with Python and Scala, and it's completely serverless. in a way is a way uh, to to find the information via crawlers and to transform that information using Python and Scala. And essentially, everything runs serverless. So it's one of the easiest ways to do ETL in AWS, because you don't need to worry too much with the operations in the day to day. Everything is kind of handled for you. It's like a bit like Lambda in that sense. Now, AWS EMR is another service that you can use to do ETL. And EMR stands for Elastic MapReduce. And essentially, if in your company you are used to do Hadoop, so essentially is Hadoop as a service in a very nutshell. So all of that Hadoop, which is open source tools for data engineering and ETL. So all of those tools can be used essentially as a service using AWS EMR. It's a bit more complex to use than AWS Glue in that if you're not used to this domain, but you have that choice in a way at your hands. Then you have services for analytics and BI, so business intelligence. And you can use, let's say, AWS QuickSight if you want to create visualizations and dashboards of your data, or you can also use AWS Athena. And Athena is a service that allows you to do SQL-like queries on top of the data that you have in S3 buckets. So it allows you very quickly to do analytics and explore the data that you have in S3 buckets. Then when you start looking for AI specific services, you will likely find AWS SageMaker. And AWS SageMaker is the AI machine learning platform in AWS that allows you to build, train, and deploy machine learning models. But it's not the only AI and machine learning service. You also have Mechanical Turk and Greengrass, which are a bit more unknown because they are very specific tools. So AWS Mechanical Turk is a service that allows you to essentially, when you have data and you want to create labels, when you want to categorize that data, it allows you to basically ask and order, ask other humans to provide labels. So essentially, like, let's say that you have a group of photos and you want to get textual labels about those photos, you can order that that you can request other humans to essentially go one by one each photo and give those labels. So it's kind of a service, but it's not really a service in that sense. So it's not a service, or as you will imagine in AWS, so it's a bit a different thing, but it's a very powerful tool because the labels play a very important role into machine learning and to using effectively getting the most out of an algorithm. Also Greengrass is in IoT, and Greengrass essentially allows you to run machine learning models on the edge device, so in an IoT device. So essentially, if you have an IoT device, and it can be even a Raspberry Pi, so you can install Greengrass on it, and it will allow you to run machine learning models directly on that device. And that's super powerful, and you can use that together with AWS IoT Core. IoT Core will allow you to manage those devices and also to ingest that data. Then other tools about AI and machine learning are the cognitive services. So things like recognition, translate, poly, comprehend. There's a bunch of other services, and these services are essentially pre-trained AI and machine learning models that you can use via an API. So think like the translate. You can send to this API a text in English, and you get in return, you will get text translated in Spanish. But you can also send the same text in English and in return get an audio file with the voice. So you can use the Poly, AWS Poly, to get this text to speech. Or you can also get speech to text. So if you send, for instance, an audio file using AWS Transcribe, you can get the textual information of that. So you can get everything that was all the words that were said into that audio file. So these services are, in a way, they are super powerful because it allows you to achieve very fast results. And they are also in the section of AI and machine learning, even though they are not models that you are going to train. They are already pre-trained. But super important services for you to explore if you are new to this field. Now, it's a bit hard to understand like how all of this kind of fit together. So I prepared this kind of reference architecture, but it's not the only way of doing things. There's not a single way of doing things. This is just one way on how this services could kind of interact a little bit. So starting from the ground up, we want to ingest data. So we want to get, of course, data into our AWS environment. And you can get data in many different ways. The data sources can also be in many different uh, systems, sensors, can be humans sending data. So it can come in many different forms. But essentially, you want raw data to be into your AWS environment. And once you have that raw data collected, you want to prepare that data in a way that can be usable by humans and machines, so algorithms. So you're going to use AWS Glue, as I mentioned, or EMR, if you like, to process and transform that data. The outcome of that will be stored maybe on an S3, on a new S3 bucket, or in a Redshift, a data warehouse. And then you will have visualization and analytics, meaning that your business users can see some nice dashboards and visualizations coming from that prepared data. Or they can use Athena to do queries on top of that data. Or if you are going to use AI and machine learning, you could use SageMaker to get that transformed data and train and build the algorithms and then deploy them in S3 bucket or in ECR or exposing them via an API in SageMaker. So this can play, there's many ways of doing this depending on what is your goal. And actually, I think this is one of the parts that I will advise you to start with, is to understand actually what you want to achieve. So picture this almost as a cycle. And AI and analytics is a cycle. So you start, the first thing that you need to start before entering this cycle is to understand what is the business understanding, and try to find what is the reasoning why you want to use AI and machine learning in the first place. And this can be very hard in the beginning. I see a lot of organizations that essentially they jump into start acquiring a lot of data and ingesting a lot of data into their AWS accounts, and then they start preparing a lot of things with SageMaker without really having a clear business goal. And I think this is one of the pitfalls, is that this can be quite consuming in terms of time, but also in terms of resources. So you want to have a clear business understanding, because the pitfall is that you might, if you don't have a clear business goal, you will end up doing a lot of engineering efforts, and then you don't get anything tangible in the end of it. You will not get anything that adds value to your business. So as an example, so if you are a manufacturing company, so let's say that you are a manufacturing company that produces large machines. So one potential use for machine learning is that you want to predict when the parts of your machine that you are shipping to your customers are going to break. So let's say that you want to do predictive maintenance, which means that you want to give, let's say, to your customers, you want to give them a clear estimation, or with certain degree of confidence, when some parts of the machine that you are selling to them might break and might need to be replaced. So you want to give a kind of prediction of the overall health of the machine. So the way that you could do that is that you can ingest this data using via IoT. So you can have IoT sensors in the machine that are sending the data to you, to the AWS environment, where you are going to prepare this data. You're going to transform this so that a predictive algorithm can work on this data, and you're going to train and validate this machine learning model based on this data, and you're going to deploy it so that the users then can use it to predict when the parts are going to break. So it is a cycle in the sense that the model needs to be constantly retrained, because the data might change, and the predictions also you will get value from understanding if your predictions were correct or not. So you will constantly keep using the data that is being ingested as new to retrain the model. And of course, you also, since you have the data in your AWS environment, quite likely you will want to visualize and do analytics on that data for humans to try to get value from it as well. So in a way, this is a cycle that continuously goes. So the parts that I found it a bit harder to explain to developers and DevOps teams were actually the data preparation and this training and validating, deploying the model. Those are parts that were that were not so clear for most people. And a lot of people didn't understand what was actually the effort to do that and why do they need to do that. So I would like to focus on these three parts, and starting with the data preparation. What is data preparation and why is this important? This is one of the most important things actually in AI and machine learning is how we prepare the data to be useful for our algorithms. So what, why, and how? What are the concepts behind it? So when we talk about data preparation is in a nutshell, transforming the data so that machine learning or analytics can use it. So this is important because machine learning is essentially algorithms, and algorithms love numbers. It's an oversimplification, of course, but we know that algorithms need a lot of data, and they need data with a good quality to be efficient. Because if you are putting data into the algorithm that is not in a good quality, you are going to not get any, it's not doing miracles, so you're going to get garbage out. So garbage in, garbage out is a common saying on this, because it is true that if you are not putting data that is with the good quality, if it's not in a particular format or with particular features that are useful, you are not going to get good results. Also, like the more data you put, in a way, it will allow you to get better accuracy in terms of the model that you are training. So you need a lot of data, and data with good quality to be efficient. And how is this done in practice is that is through a process called ETL, which means extract, transformation, and load, which means that extract means that we are reading the data into a usable format like JSON or CSV, and we're going to take that data, we're going to transform it, meaning we're going to clean it and transform features so that the data can be usable by the algorithm that we are planning to use. And then when we transform that data, we are going to load that new data into a place that can be used by that machine learning platform. So in this case, could be SageMaker. So it means that we are likely going to write it into a new S3 bucket or into a data warehouse if we need some certain performance. So essentially, in a nutshell, is this. But how do you actually transform this data? I think it's also a bit. It's not just about. It's usually not just about running a small Python script to do something. Like, you need to understand what you are doing and why. There are many ways to transform data, and these four are just like four of those ways to transform it. So imagining that your data has it's a receipt, a purchase receipt of a coffee shop, and let's say that you have like you are selling medium coffees, small coffees, or large coffees. If you have this textual information in the receipt, it's not that useful. So you probably want to assign certain numbers to the size of the coffee. And of course, since the order is important, you want to preserve the order, because of course, a large coffee should have maybe a higher value than a smaller coffee, so that you can distinguish that one is bigger than the other. Also, if you have let's say that your data source is a text, and extracting transforming text can also be very tricky, because what does that mean in practice? Well, depending on your use case, but let's say that you are trying to hunt for spam into a text. So that's your use case, that you have a text and your goal is to identify if that text might be an email with spam. So essentially, you will probably be interested to use a technique called n-gram with the size of 2 or with n equal 2 to try to extract the bigram. So you will let's say that if you have like, this is a sentence, you'll try to extract this is a sentence. And why is it important to be bigrams? Because, well, maybe you are looking for the words click here, and click here could be something that will likely be, could indicate you that that text is a spam. So that might be something that you are interested in. Or let's say that you have, your data set has personal information, it has their age. You might want to, on the age, you might want to group those ages into what we call a quantile binning, which is like grouping on the similar value. So like, let's say that you want to uh, group them into 0 to 17 are minors, 18 to 64 they are adults, or 65 over 65 they are senior. So you will likely want to transform the data so that you can already make this in something that can be useful for the algorithm, if it makes sense. You also might have the case that your data is in a quite, a bad shape, in a way that might have a lot of missing fields. And if you have a lot of missing fields, you might want to use, you might want to predict what will that field be, or the value of the field be. And you can do this using maybe supervised learning, or you might just take the median of all the values and put that. Or you might also want to drop those rows that miss a lot of data. Um, Likewise, you might also have the inverse problem, which is that you might have too much data, too many features. And if you're putting also too many features in algorithm, might not be good. So you might want to use something like a principal component analysis algorithm to reduce the amount of features before you use a machine learning algorithm. So there's many ways that you can use to transform data. And once you transform the data, it is important then to then use an algorithm to build intelligence on top of that data. So it's not magic, it's mathematics. And I want to explore also what that magic, in a way, what that not magic means. So an algorithm is very similar to an heuristic, but an algorithm gives you consistent results. So it's something that you know what you will get when you put something. So you put something and you know that the outcome will be that. With an heuristic, is more like a rule of thumb. There's no consistent outcome, but they're a lot easier to implement. So that's mainly the two differences between an algorithm and heuristic, in a very simplified way. Also, you probably heard supervised learning versus unsupervised learning. And what it means is that when we have supervised learning, it means that we are going to do the machine learning model training, and we usually have labels, meaning that, let's say that you have a bunch of images with handwritten numbers, which is actually a very popular data set called NIST. And let's say that the label could be that if you have a handwritten number of 0, a label will be, well, this is a 0. Because otherwise, how is our algorithm going to understand that that is a 0? So the labels will help, in a way, the training. When we have unsupervised learning, it means that we might not have the labels, and we probably will not do the training, or meaning that we will not have supervision. It means that it will try to predict maybe what will be those values. So how can we use algorithms in AWS? So there's a lot of famous, in a way, machine learning algorithms, and you have all of them, or not, maybe not all of them, but you have a lot of them ready to be used in SageMaker. So if you're using SageMaker, it comes already with a lot of built-in algorithms. But you can also purchase some algorithms from the marketplace. So some organizations are selling their own algorithms, and you can purchase them from the AWS marketplace and use them in SageMaker. Or you can build your own algorithm, and you can create your own mathematical model, your own algorithm, and you can place it in a Docker container and then use it in SageMaker. So you can use algorithms in many different ways in AWS, but just remember that there is a lot of built-in things in SageMaker that are ready to be used. So you don't need to reinvent the wheel in a lot of cases, and you should explore them quite a bit. And what are, when we talk about algorithms, what is this about? Like, what type of algorithms? So there are too many algorithms. There's a lot of algorithms. And of course, it's very hard to cover all of them. Even covering the types of algorithms is already quite a challenge. But let's say that you have algorithms for, let's say, clustering, to classify things, to detect anomalies, to do analysis on text, to do reinforcement learning, or to do regression. On the reinforcement learning, I think it's actually maybe the easiest one to explore, because if you have been following AWS for a while, you probably heard about AWS Deep Racer, which is this autonomous car. So this car that follows a certain path, certain road. And essentially what is happening there is that we are using reinforcement learning. So basically, picture a car with the camera, right? And the car is going through the road, and if it stays on the road, it gets a positive reinforcement. But if it starts deviating from the road to the sides, the camera will detect that, oh, this is something that is not the road, and so we might punish it and say, like, well, this is not what you should be doing. So in a way, if you know, Markov decision process is essentially something like that, that we will always try to find the path to the greatest reward. And in the case of AWS Deep Racer, the greatest reward is that if he stays on the track. And so that's one type of algorithm. There's a lot of types of algorithms, and you can use one or a combination of multiple algorithms for a certain use case. So it's not one size fits all, and there's not really right and wrong answers. You can try different combinations and different things. You can also tune the parameters of the algorithm to achieve more accurate results. So, like, taking this example of, I mentioned already this MNIST data set, where you have, it's a very famous data set where you have basically images of handwritten numbers. And let's say that you didn't have the labels. Let's say that you didn't know what was the number associated with the image. You didn't have any textual information on that. So if you wanted, you could use, for instance, AWS ground truth, and you could take that data set and you can send to a group of people, and that group of people will give you, they will go one by one visualizing the images, and they will give the labels to it. But you can also, let's say that you could also use an algorithm, a machine learning algorithm, to try to predict what the number on the image is. Of course, it will not be as accurate, but it's a way that you could use to try to predict what is the number that is handwritten in that image. And you could use a clustering classification algorithm called k-means to do this. So for instance, it's an unsupervised learning. So meaning that we don't have labels, and you will not, in a way that it will run, and you will not be able to, you don't need to supervise it. So it will run, and it will try to gather this list of attributes and attempt to cluster them, to group them based on how similar they are. And the similarity is basically a calculation between the distance between the attributes. Now, attributes are super important here, as you might guess, because let's say that you have, imagine that it was not handwritten numbers, but let's say it was something more simple, like shapes, like a square or a triangle or a circle. And an attribute could be, of course, how many corners there is, but it could also be the color. So in this case, a triangle and a blue triangle and a blue circle will be a lot more similar than a green triangle and a blue triangle. So the attributes and how you group them varies a lot. So you need to be very cautious with it. But you could use this k-means algorithm to try to predict what will be the numbers, and you actually get some quite okay results with it. Now, how does this work now? You train that algorithm, and how do you create value to your business? Like, it's sitting there. You went through all of that. How can you actually deploy that into the AWS architecture? So taking a bit, almost the same example that I showed you before, but a bit more elaborated now, that we ingested data, we transformed the data. That data was then usable by SageMaker, but you train that in SageMaker. So how can you deploy now the model? So you can use you can have an offline usage, meaning that you can take that model and put it in an ECR, a Docker container, and use it somewhere else. Or you can also expose an API in SageMaker and have your application querying that SageMaker API. So that's the online usage. So you can use that to one or the other methods to deploy the model. So it doesn't mean that you just because you train the model in AWS that you need to use AWS to run the model and to use the model. So you can actually run it in different ways. Now, what is a good model and when is it good enough? So just keep in mind that the goal of machine learning is to generalize, not memorize, meaning that you want to send 60 to 7% of data to be trained by the model, and then use the remaining 20 to 30 to actually test if the model is being accurate or not, because the goal is to generalize and not memorize. You don't want to send all of your data and then getting a new value from somewhere, a new field from somewhere, and the thing completely cracks. So if you have a low training error and a low testing error, you know that you are in a good place. But if you are training and you have a low training error, but then you have a high testing error, you know that something is fishy. And of course, if you have a high training error and a high testing error, like, oh, run, because then, like, of course, nothing will work. And you want to also to continue monitoring and evaluating the model, and meaning that you can use CloudWatch to see how the model is performing, but you can also do a more pragmatic approach, something like you can train two different models, and like one is being used by the majority of your clients already, but then the new model is only being used by, let's say, 10% of your customers. And basically you can then compare. Let's say that you are running an online shop and your algorithm is providing recommendations. Your model provides recommendations of what products, suggested products that your customers might want to buy. So you can run this two in parallel and then compare what algorithm actually yield better results. And remember that you can also adjust these hyperparameters on the algorithm, so you can always try to adjust this to get better results. And even in certain cases, you might want to change the algorithm altogether. So just in a way, keep in mind that it's a cycle. So you need to ingest data, prepare data, train and validate the model, deploy the model, and then you always need to continuously, ingest more data and retrain the model, because of course the data will change. So if you are running an online shop, you're going to sell more products. And if you're running recommendations, what was valid maybe 6 months ago is not valid today. So you want to have this cycle that you are always doing this with certain frequency. Otherwise, it will not age well. So keep in mind this, and hope this was useful and that this gave you kind of an overview and a crash course of all of this data science terms. And happy to take any questions now, or feel free to reach out in social media via Twitter or LinkedIn. Thank you so much and have a nice day.